As a scientist, the answer must be, I don't know. And by the way, that's not a cop out. It's the answer to most questions that we ask in science. I don't know, or I don't yet know. So for me, that question, we actually are making a ton of progress towards. I mean, frankly, during my professional lifetime, it's probably the question where we've made most groundbreaking discoveries. When I started my kind of master's degree in astrophysics, we had no planets elsewhere other than the ones in our solar system. In the meantime, we have thousands of those planets, and some of them look awfully like our own, kind of relative to the data we have, which are really, really, really sparse. So we're on that track towards, a belief, or kind of a sense that, life, just like planetary systems, life could also be very much distributed in the universe.
Hello and welcome to The Knowledge Project. I'm your host, Shane Parrish. This podcast sharpens your mind by helping you master the best of what other people have already figured out. If you're listening to this, you're not currently a supporting member. If you'd like special member-only episodes, access before anyone else, searchable transcripts, and other member-only content, you can join at fs.blog/podcast. Check out the show notes for a link. Today I'm speaking with Thomas Zurbuchen, also known as Dr. Z. Dr. Z is the head of science at NASA, running a $7 billion a year science program covering multiple disciplines, including the world's top research program in earth science, planetary science, astrophysics, and heliophysics. This episode is incredible. We talk about things we've learned from running experiments on the International Space Station, our missions to Mars and whether we'll ever colonize it, how space is governed, and decision-making. In fact, this episode is a masterclass in decision-making from someone who routinely makes billion-dollar decisions. It's time to listen and learn. Can you tell us in your own words how you got interested in astrophysics?
I grew up in the mountains in Switzerland and frankly, quite isolated. I grew up in a quasi-Amish community with a father who was a religious leader. And so I didn't have a lot in my life, that other people have. The only book I really read was the Bible. And, so what I did have, though, is an amazing environment in that little village where I grew up. I saw the sky kind of in a way that, frankly, I've rarely ever seen since my youth. And I was outside a lot at night, on my back, frankly, on the roof, and looking at the stars. Over time, I bought a map, a star map, and I started looking at it. And so for me, the stars were always both a goal, but also an escape. For me, it was just amazing. So I started, of course, asking questions just like we all do. That was the start for astrophysics for me.
Do you remember what some of those first questions were?
The most important question really is about, is somebody else watching the other way? I mean, for me, it just, what is there? Just the whole point, right? Growing up in that religious environment, I thought a lot about bigger purpose and bigger things, like, with the name the Lord, perhaps, or with the name creation. For me, really looking at the stars, the patterns of them, the fact that they're there the next day also kind of made me really ask, what is it? How does it actually look, right? And what can, what's the relationship of that amazing sky to us here, like to my little self on my back on the roof in that little village? What is that big thing? You start opening up books. My godfather gave me the first book. It's still in my office, by the way, at NASA, really about the possibility of exploring those stars. And, it just keeps on going, and that question becomes more intense.
Do you feel, what is your take on that? Do you think that there's somebody out there watching us?
It's kind of, first of all, I believe it's very likely, right? I mean, as a scientist, the answer must be, I don't know. And by the way, that's not a cop-out. It's the answer to most questions that we ask in science. I don't know, or I don't yet know. So for me, That question we actually are making a ton of progress towards. I mean, frankly, during my professional lifetime, it's probably the question where we've made most groundbreaking discoveries. When I started my kind of master's degree in astrophysics, we had no planets elsewhere other than the ones in our solar system. In the meantime, we have thousands of those planets, and some of them look awfully like our own, kind of relative to the data we have, which are really, really, really sparse. So we're on that track towards, a belief or kind of a sense that, yeah, life, just like planetary systems, life could also be very much distributed in the universe.
I have a million questions about space. I was so excited when you agreed to come on. So one of the first questions I wanted to ask is, my kids actually proposed this, which is what's the most interesting things we've learned from running experiments on the International Space Station?
It's a really good question. I do believe, and it depends a little bit who's asking, right? So for me, I'll give two answers depending on who's asking. I think the most important one is really kind of a series of answers that relate to one question, and that is, how is the human body or even life itself kind of evolve or change without gravity? And there's important, very, very important work that has happened relative to our bone structure, relative to our visual system, but also now relative to our just genetic expression, right? We have with the twin study that an identical twin went on the space station for a long time. The other one stayed on the ground. With that twin study and the kind of generosity of those individuals to make the DNA public, there's an abundance of research that really talks about how gene expressions are changing in space. So for me, that is a super exciting part, and a question we can't really answer on the ground. The other one, I just want to say, the space station has been the site of much research, and there's a lot of experiments hanging on the outside of the space station. And for me, probably the most exciting one relates to neutron stars. They're these kind of high energy, high density kind of stars that we're frankly right now measuring kind of the ingredients of, and we're doing that from the outside of the space station using a telescope kind of that's taking advantage of that unique orbit and the enhanced data rate. So that would be the second answer.
How do experiments work on the space station? Are they coordinated across countries, or is the data shared? Does each country do their own experiments?
For most of the data, and let me just talk about NASA first. For all of our experiments, we have a policy of sharing all data. And I love that because, frankly, so much of the work we do, whether it's about astrophysics and especially about Earth science, we're all better off if we share all the data because it's kind of a common good, right? As the taxpayers are paying for it, let's make it as useful as possible. And it's incredible what people figure out with those data. So what we have done in the space station work is we have actually created partnerships in which multiple countries are participating, and they have their own channels up there, and there's an integration board that kind of makes sure that we're not doing twice the same thing, that we partner when we can, but we encourage and empower both government agencies but also companies to put work on the space station and then coordinate that. Now, in what we have done, especially for companies, we have kind of adopted IP laws in a way that does not undercut the ability of actually commercializing some of the results that are there. That's deliberately. But for the science work, it basically is public data where we're trying to enhance kind of rise all boats, right? Kind of in science. That's a principle we really, really deeply believe in, and I think it's exactly the right principle. It was invented long before I came to NASA. It's something that we went through in the last 20 years, and it made us all much better.
Are there specific examples of things we've learned about the immune system or sleep from space that we can apply on Earth?
There are lessons about sleep, about the immune system. I'm not sure whether any of them kind of is in the nugget form in which I could just basically say, well, this is what what we know, for example, the various levels of sleep, right? Kind of the astronauts, just like here, are kind of being observed constantly. They're wired, the way it's in the movies. It is the way it happens, right? Kind of we make sure that the astronauts are healthy, and we are, like how they're sleeping, kind of the depth of sleep. I mean, I talked to a number of the astronauts. Very easy to just recognize, hey, this is a really different life, and it's hard. It's, I mean, give you one example. You close your eyes, you see flashes going through your eyes. Why? Because cosmic rays, that come from the deep galaxy, from exploding stars. They're out there. Most of them never come to the ground because between, if you take a square centimeter and go all the way to space, there's a kilogram of air per square centimeter that shields us, right? So we're very radiation shielded. Well, if you're in the space station, that is not the case, right? Because you're on top of the air. So basically what now happens is that radiation goes through your body. And if you close your eyes, you see these flashes that are going through your eyes. And, many of the astronauts, some of my friends have told me, is like how kind of tough it is to try to ignore that when you want to fall asleep first, right? These kind of flashes that occur in your eye. Just one tiny example.
Oh, that's so cool.
This episode is brought to you by Google Chrome. You think you know a browser, but Gemini and Chrome? That's new. It can help you with practically anything on the web, like restoring a vintage motorcycle from a 50-page restoration blog, or finally break down that long article you've had open for weeks. Gemini and Chrome is here for it. Ready to make anything online make sense? There's no place like Chrome. Check responses, setup required, compatibility and availability varies, 18+.
When you need to build up your team to handle the growing chaos at work, use Indeed Sponsored Jobs. It gives your job post the boost it needs to be seen and helps reach people with the right skills, certifications, and more. Spend less time searching and more time actually interviewing candidates who check all your boxes. Listeners of this show will get a $75 sponsored job credit at Indeed.com/podcast. That's Indeed.com/podcast. Terms and conditions apply. Need a hiring hero? This is a job for Indeed Sponsored Jobs.
Can we talk about the Earth's magnetic field and how it shields us from debris? Am I getting that right?
The Earth magnetic field, it's by the way, it's one of those things. If you really ask in detail, we still don't fully understand why it occurs, and kind of the more we know about it, the more it kind of makes us learn. For example, Mercury has a magnetic field, the Earth has a magnetic field, Jupiter has a magnetic field, Mars does not have a global scale magnetic field, neither does Venus. And so we basically, we learn from that. Okay, so what does the Earth magnetic field do? So what it does, it stands there, like a dipole from north to south. And what it does is the very particles I just talked about, but especially lower energy particles, the ones that come from the sun, they come into the magnetic field and they hit the magnetic field. And whenever they hit the magnetic field, think at the equator, right? When the magnetic fields look like a dipole, it's kind of right over the magnetic field. It turns the particles around. So it if you want, it shields, the magnetic field shields the inside of the Earth, including all the way down here, but also in the space station, shields us from energetic particles, debris, which are dust pieces and kind of, some of them human-made, kind of spacecraft that blew up or that are no longer used, or upper stages that were used, of course, to propel spacecraft up there. They're way heavier, so the magnetic field doesn't really have a huge impact on them.
And that's also how we get the northern lights, right? So it's the reflection off of that debris that sort of refracts the light differently.
Yeah.
Or
so think of that particle I just described at the equator. So at the particle at the equator, it goes away because remember, the magnetic field force is always perpendicular to the magnetic field itself. Now let's go at the polar region. At the polar region, the magnetic fields are coming in, right? Kind of just look at, Google magnetic field of a dipole. You see the magnetic fields are coming in. So up there, the particles are like a funnel. They're coming down. They're not deflected. They're like funnel coming in. And they come in and they hit the atmospheric oxygen and whatever is there. And it makes them light, like a neon light or whatever, a light that you have in which kind of high energy particles are exciting them and they radiate. So the northern lights are energetic particles, both from the sun, but also from the back of the Earth magnetic field, kind of funneled into the top, into the polar regions, and igniting, if you want, the spectacle of light.
You mentioned sort of like satellites and unused spacecraft, I guess. What happens to them after they're done? I mean, do they just float around? Do they get sent on course to the sun? As we put more and more satellites into the air, does it become a problem for launching rockets? Or
So if I was organizing the kind of whole space flight according to its challenges, this would be a top 5 challenge that you're mentioning. It may be even a top 2 or 3 challenge. So basically, the issue is these particles, especially in low Earth orbit, right? Most spacecraft that we have are in low Earth orbit. The second most site is in geostationary orbit. That's where your, spacecraft are that do both weather observations, but also, the TV satellites. The antenna on the roof points towards geostationary orbit. That's why it can point one place. It doesn't have to move at low Earth orbit. There's a lot of spacecraft, thousands of spacecraft that are operating, and tens of thousands, if not hundreds of thousands of debris. Now, so what happens is, depending on where you are in height, that debris stays there for decades. And so basically what actually is one of the biggest challenges we have is, as we launch into that space, because of our history, but also because of new things, that debris is frankly becoming a real challenge. Now, just imagine the speed by which these spacecraft move are kilometers per second. That's also the speed by which the debris moves. So what we have is we have an observation program, both by the Department of Defense, but also other places, international places with telescopes, and we try to catalog all the debris. So on an average month, we have one, sometimes multiple almost hits. So sometimes we have to fly a spacecraft away. I have tens of spacecraft that are there operating. We have to move it away to make sure the debris can pass. Those are fine. The ones that really worry me are the ones that we don't see. Like if you took a sugar cube worth of metal and you shot it, at 10 kilometers per second. You shot it against the spacecraft. If it hits it at the right place, that spacecraft is over, right? So if it's tiny, it may take a solar cell out. If it's, you see, the size really matters. So we have a problem as an international community that, especially low Earth orbit, is clogged with debris. And it's really one of those things. I think in the next 10 years, we have to solve it. We have to, in fact, clean that garbage. And also what's important, the rule number 1 in digging holes is stop digging, right? So we have to make sure that everything we launch, we either fly out or we create such a short timeline that within years it's gone, right? So it's out of the space. The upper atmosphere kind of has a drag force and it falls onto the Earth like a meteor, an artificial meteor, and it disappears. So that's a really critical problem.
You mentioned that was one of the top maybe 5 challenges. What would be other contenders for the top challenges?
Well, I do believe that one of the things we really want to be careful about is to keep space peaceful. And I think that's something we've been watching with trepidation. We've signed treaties both in the U.S. and otherwise, and we see, and it has been discussed, we see some countries, nation states that are out there that are, really putting in question whether they're serious about the peaceful utilization of space. And it is really worrisome because, of course, it is, they can use space like other countries use. They can put telescopes there, observe whoever they want to, their own people or other people, right? They can do that, but they can by law, right? But they cannot, for example, weaponize space. So for me, kind of, if you ask me, kind of my kind of in low Earth orbit, what is my biggest worry right now? It is that we take the common good of space that we've, over decades, we've used that way, in a non-interference basis, with international community, that we take that and move it into a place where this becomes a domain of war almost, or a domain of potential war. And that, and frankly, we're moving at a larger speed than we would like in that direction, unfortunately. And it's not, because we want that. But of course, we observe what is happening.
Do you think that's inevitable, that it becomes another frontier for, say, war, for example?
God, I hope not. Right? I mean, that we've seen in history, we've seen cycles in which we armed ourselves to the teeth. And we said, this is insane. Let's step back. Let's get rid of all these nukes. And we have done that with people at times. We were in a Cold War with. And so for me, my hope is we get to a place in which we kind of really say, look, we're going to create lines and we're going to accept those lines. The fact that people say, oh, we're going to do this and that, that's one thing. It's the important thing is that we, if you look at the Cold War, we went and checked each other, right, and made sure that we followed the rules. Right. So for me, I think, there's a fork in the road in the next decade or so, and in which we do that. Needless to say, the United States put a space force together in part because of that challenge. Is that space deserves a lot of attention, and we can still use space as a domain from which to support the U.S. or our allies and so forth without crossing that line. But my worry really is that that discussion is one of the discussions in the next decade that's really serious.
Are there other things to come to mind as like big challenges over the next decade?
Well, I think the big a challenge now in this case, I don't know whether it's a challenge or an opportunity. I think we're at the verge of really opening space for commoners, right? For my family, your family, right? To do a trip to space and utilize it both as a commercial entity by imaging the Earth, for example, and selling those images, those data, that information, or also as a tourist destination and so forth. And so for me, if we can do that, right, it creates a very different dynamic in this whole thing, right? And so for me, that's also decided, I would argue, in the next 10 years, right? It's frankly, it's incredible what has happened in the last 20. The question is, where are we in the next 20? So for me, it just, that's another big question. And, if that is failing, right, that space is solely the domain of governments, right? The question we just had about one of my worries, right, is a totally different discussion than when others are there also, right? In which we basically say, hey, look, this is, just like we do a trip to Paris, let's do our anniversary trip to space. Right. And you say, well, that's crazy. No, it is not. That is precisely what 5 companies are working on right now. And for all I see, they're successful. It's looking really promising. It's moving into the domain of entrepreneurship. So in other words, it's no longer a technology. The question is, does the business model close? So that's what that one is.
How is space governed? Like, can I just start a company and like shoot stuff into space?
So each, the space is, the United Nations Office for Outer Space, as, with its signatories of the relevant, acts that came internationally. For example, it says we will use space as a common good. We will not weaponize it. We will be act on a non-interference basis. So those things are the international framework. Then the national framework, each country is now responsible for access to space. So for example, if you wanted to launch and you're in Canada, you would work with your country on how, in fact, the access to space. Are you, for example, compliant with the orbital debris guidelines? Right? Are you compliant with the frequency interference stuff? How are you going to communicate? Those checks are done by your nation state, and then you can launch based on that. So it's really, there's both national and international community that works together on those things. We know, of course, whenever there's a launch somewhere. So it's not like you can't hide. If there's a launch, we know. It's almost, everybody knows where there's a launch. That's why we actually tell everybody there's a launch. There may be, we may be launching, or I'll just call it, the Russians may be launching a top secret asset, but they're saying we're launching.
They're just not talking about the payload, but they're just telling you that they're launching, and they'll give you the trajectory and everything, I would imagine.
Exactly right. So that's how it's regulated. Yeah.
How does that work in the future in the sense of we'll see more and more private corporations innovating in space? And I want to come to SpaceX later specifically. But how does that regulatory body work? I mean, ultimately, there'll be countries with less regulation and more regulation, and you could locate your business in any of those countries.
I do believe, back to my top five, this is one of those also. As always, the speed of innovation is the relevant speed on this one, right? And the speed of regulation, like so many places, it's just not matching the speed of innovation, right? And so it's because of that I worry, right? It is because of that you believe. I mean, it needs to be. It can't be a leaky bucket, right? It can't be that certain countries just pollute the space by whatever means, right? Whether it's the frequency, the communication piece, or whether it's the orbital debris piece, or whether it's how they're setting their orbits. They need to be part of a common community that actually enforces those standards and holds them. And I think that commercial, by the way, the commercialization of this is a great story. So for me, especially from the US perspective, that is the goal, right? Our goal is not that in 50 years the government does the same stuff that we did 50 years ago. That's crazy, especially when it's a research entity like NASA. We want to attack the next frontier. We want to go beyond what's possible today, increase the box of what's possible, and then let the commercial entities deal with that. So for me, it's what I call a good problem, but it's a problem nonetheless.
So with something like Starlink, did they just need US approval, or do they need to go around the entire world and get everybody's approval to launch those into space? Like, how does that work?
It was the U.S. approval, so the relevant U.S. entities both focused on launch, on the frequency, all this stuff. Was approved in the process that is agreed upon in the United States. So they went up there. Of course, what happened, is the element of surprise is always there when you're working with innovation. So they were a lot more bright, and everybody looked at I imagine myself in Switzerland on top of that roof. I would see Starlink, right? I mean, it's like you can't miss it, right? And that raises questions that are beyond the regulatory, right? Is there a right to a dark sky, right? So it's questions like that, especially as an astrophysicist, like how does that affect the future observation? I just want to tell you, SpaceX and the Starlink team have been nothing but collaborative. They went and faced the astrophysics community. They're actively darkening their bodies, right? Their spacecraft. Frankly, it was people didn't want to do this, right? It's not that I don't care, right? It's really hard to do some of these calculations the right way, and frankly, sometimes you don't know what the question is you're supposed to ask, right? I mean, who would have guessed that that's going to be the big discussion in Starlink? Right. Of course, having internet everywhere is a great equalizer. I mean, I worked on this when I was a university professor I worked with Google on this problem, right? And did due diligence of company investments with them. And so for me, that's a good thing. And SpaceX is really pushing the envelope. But yes, this is an important part.
Well, let's come to SpaceX a little bit later. I want to. One of the coolest things I think you're working on is a Mars sample return, which would be humanity's first round trip ever to another planet. Can you tell us a little bit about that?
Yeah, I'm so excited about it. So first of all, in this summer, we did launch a mission called Mars 2020 Perseverance, and it's basically a sampler.
That was in July, right?
It was in July. Yes, in July, the 30th of July. I remember it exactly, how it took off, and it was incredible. It was named by a schoolboy, is up, called Perseverance, and it's like the best name ever, especially for the time we're in today. And it's on the way to Mars. It's beyond halfway to Mars, and it's going to land in February 21. It's going to land on Mars, and then it has one task that it really has to prioritize on. And that is to collect samples, identify and collect samples. So we're going to land into a crater, a former crater that was a lake, used to be a lake. We know from remote observation. So we're going to collect samples kind of in places where on Earth we would go find fossils, right? So that's where you would go. And so basically we're going to collect those samples in 26 or 27. Our next two spacecraft will take off, one in 26, one in 27, we think today. The first one will go up there, and its job is to fly to Mars and using a propulsion method, ion propulsion, electric propulsion, moving into Mars and waiting. So it's kind of the carrier ship. So it's there with camera and comm. Then the other one comes, and it puts a rocket down on the surface of Mars. It's a total functional rocket. It lands a rocket. Then the rover that we have will go and drop off samples. By the way, just because we don't know whether that rover will work, we have a sample fetch rover that actually is done by Canada, and it may actually turn out to be the most important part of that entire piece, kind of to go pick up kind of deposits of these sample kind of flasks that we have, super clean things, then put them on the spacecraft and at that launch vehicle, go up and then drop kind of an orbiting sample satellite, put it there. Remember the thing that's in orbit and waiting? It's going to put it up. You know that Austin Powers movie? It's that, right? Kind of just to scoop up that kind of Easter egg, right? That's up there, kind of with the sample in it, then come back to Earth and drop it onto the Earth. So that will be the first round trip. It's international and science driven, just like we should do those kind of big leaps.
Do you think we'll ever live on Mars?
I believe so. I don't think it's me, or it may be at the generation of my children, but it's not my generation. I think we will go to Mars with humans in my lifetime, for sure. I think
and colonize it.
I think over the timescale of multiple generations, I think it's very much possible that we could stay there for a long time. It's not clear how, right? We don't know enough. And it has everything to do with the resources that are there. And so for me, the question is the way we're going to live there like we live in the Antarctic Research Station, right? There are people living there, but it's kind of a tough life, right? It's in the middle of ice. Airplanes come and drop them off. They stay there for the summer, and then, the southern summer, and then they take off. And there's kind of the only people who are there are just, that go through winter are very healthy individuals who, just keep the thing afloat. So it doesn't, it's still ready for the next summer. So that's one version of living, right? And then the other version of living is like we have here on Earth, right? Go to an island and build houses and live there with our families. And on that whole spectrum, right? I don't know where we're going to end up. If I had the hypothesis right now, and I know many people, kind of depending on who you are, some people think there are thousands of people who will live on Mars. It's like that may very well be. So that's more on the island side of things. Instead of Hawaii, an island in Hawaii, go to Mars, find resources, do that. Perhaps even terraform Mars. That's what people talk about. Make it a different planet so we can live there. One good way of counting is just number of miracles you need, right? This is a 10, 20 miracle type of scenario. The other one, kind of the Antarctic Research Station, is maybe only a 5 miracle thing. So it kind of, the path to that certainly goes through the Antarctic Research Station, right? First we need to do that. That's what I'm focused on. And, I understand Elon Musk and many others, they're talking about that other world. I don't think, so if again, I don't know. Never underestimate the power of innovation. That's really important, right? But what I want to do is just break down these, kind of take the first few miracles down, right? Because it's good for all of humanity. Just take them down, put them in the bucket of, from the miracle bucket into the bucket of that's possible now. So that's what I'm going to do.
I'm curious as to what we'll find on Mars. Will we find materials that are, obviously exceedingly rare, but maybe they're useful? And in which case, does Mars become almost a mining colony? And then we have another race to see who can get there first and who can extract these, because we're eventually going to run out of these rare Earth materials. And if we find substitutes on other planets, how do you see that playing out? Or am I just like way too far in sci-fi land right now?
No, I think this is our lifetime kind of issue. the mining colony. I'll give you, I think what you said about Mars is highly appropriate. Resources relate to living there, living off the land, but it also is creating business models that make it viable. It's feasible and viability, right? Both matter. I want to talk to you about another celestial body just to amplify your point. It's called Psyche. It's, like Psyche, like the psyche in me, Psychag. So it's an asteroid. We think it's a failed planet. So it's a planet that has a core a metal core and enormously precious, if it's true, right? The size, we know the size, we know its orbit. We're building a mission. We're going to launch in 22 to go there and go orbit it and learn about it. But assume this is really a failed core. That body has more value than any other body we currently know, because frankly, we cannot get that from the Earth. Digging a hole into the Earth to where we need to go is actually harder than just going out there and collecting that. And so for me, I think the mining world, that the mining approach to the world is in space is inevitable. I mean, it's something that will matter for both purposes, again, to survive, but also to build new commercial entities. And that's why it's so important that we regulate it up front in a way that actually protects those environments. I mean, for me, I think Mars is beautiful in its own right. Look at these images. It's incredible. We don't want to destroy it, right? And we know we've learned a lot on Earth, how to do that, right? And we should include those lessons there and not get into down the road so far that we say, oops, we're back to where we were or on Earth, in which we have an environment. So again, the regulation and innovation speeds need to adjust, right?
Most people live in cities, so they don't get to look up and sort of see all these thousands of stars. I remember the first time I ever went to Colombia, and I was in the middle of a rainforest, and I looked up and there was like thousands and thousands of stars. And it was just the most incredible experience. And then you see, the Hubble, and you see these low orbiting satellites. And it was really interesting and startling to see the sky with such clarity. When you think of an asteroid and landing on the asteroid and like extracting materials, do you think of that as we're landing on it and we're going to extract it and bring it back? Or do you think of it as we're going to redirect the asteroid back to Earth and bring the whole thing back somehow?
It depends on the size of the asteroid, right? The energy that it takes to redirect this, depending on the size and the orbit it has, is almost infinity, right? Relative to what we have. If you looked at Psyche, it would be the former model, like landing and extracting and bringing back. And of course, that puts into the value chain everything from launch to extraction to, the whole risk you have to offset from the uncertainty, and all the way down to, so the investors wanting to make money from it. So it's a really tough business model. You could do an experiment right now and basically say, suppose I took one of those big rockets, take the biggest rocket we have, and suppose by whatever miracle I go to that asteroid and I can go there, I pay for the rocket and forget the physics. I just go there and I fill the whole thing full of gold and I bring it back and I land. Do I make or lose money? And the answer is we're starting to make money because launch is so much cheaper now than it was. That is in part because of that commercial force. But it's not by enough yet, right? So you want to make sure that you upside rare earth metals, by the way, are actually worth more, as as gold, right? In many of these applications that really depend on them, and so we want to do that right. So we need to learn more, right? We're just scratching that surface, but that's where we're going, I think.
You manage one of the largest budgets in the world, let alone science budgets. I think you're $7-8 billion a year. I mean, that tops most S&P 500 companies, most Dow companies. You're allocating more money into science than probably anybody in the world. I'm curious as to what's the hardest part of that job and why?
I think the hardest part of research is always to find that edge, right? So if you really look at the best research, I think of it like I'm a mountain guy. Think of it as like walking in the mountains on that ridge, on the one side is the irrelevant. We've already proven it. It's easy to do research there. It's safe. You get tenure, and every professor, is fine doing it, kind of twiddling around, and you can make a lot of money there. The other side is the impossible, right? Research questions don't only need, frankly, the right question, but the right time for that question. And the hardest part is to build programs that have that push that edge at the maximum speed viable. That requires that you learn how to fail. You're going to every once in a while drop down this way and drop down that way into, and what you really have to do, especially the ones that fail because they went too early, you want to protect them. You want to protect your innovators, right? Because that's important. So for me, the hardest part is really to set the program at the right speed of innovation, and allow for experimentation, for iteration, as opposed to kind of being that colossal that kind of slow organization that just wants to make everything safe, which of course we want to be safe, right? That has to live in our brain too, because when we make an investment of $3 billion, like that Mars 2020 Perseverance rover, right? If we make that investment, we want to do what we can, right? To do that. So that's the hardest part, I would argue.
Did you know Sam's Club isn't a store? It's actually a club. With cool finds and like a whole community. It's a club.
Of course, Jason. It's in the name. Sam's Club.
Oh, yeah. Come join us. Sam's Club.
Get business done with the new American Express Graphite Business Cash Unlimited card. With unlimited 2% cash back on all eligible purchases. Unlimited 5% cash back on flights and prepaid hotels booked through American Express Travel Online. And a flexible spending capacity that can grow with your business. You'll have the confidence to keep building. Apply today and earn a welcome offer of $1,500 cash back after you spend $50,000 in qualifying purchases on your new card within the first 6 months of card membership. Terms apply. Learn more at go.amex/graphite.
I'm curious internally as to how you balance that and how you think about, okay, well, we're investing $3 billion and we need to eventually ship this. But on the same token, the money at stake and in a public way too, it's not even a private company losing $3 billion. It's the public that would, be losing $3 billion. How do you think about those decisions and how do you make them?
So first of all, you recognize that the launch is an irreversible decision. Like, and if the moment I say go, it's done. You don't get it back. It is over, right? So it's irreversible. So basically, whenever you make a decision like that, and many people do that in the business world too, right? Kind of these kind of one-way doors, I think, as others call it, kind of you only go through it once. The way you do it, I believe, is you recognize that you want to make the decision well-informed, and with all the scrutiny up front. So the way I make that decision is, first of all, I don't make it alone. I put in the room the best people that I know, kind of from the engineers, but also the policy people. And, and I actually have people who don't report to each other. Like I have an engineering organization, just the way we built NASA over decades, that we have an engineering organization that talks about just engineering without any other encumbrances, right? The question just is, will it work? What's the likelihood for it to work? There's one that talks about safety just that way. Is it going to be safe, right? Kind of no other if then, so that's their focus. And so you basically, the way you make the decision is you bring together that kind of course you work. You recognize, by the way, the most important thing is to empower the team, right? Frankly, I'm not the most important guy in this. I'm just making the decision to live with it, and I'm the guy in the congressional hearing, right? If something goes wrong. So everybody knows that, right? So I will make the decision. And it's not a vote. It's one decision by one signature. The only signature that matters there for most of these missions is mine, right? Because I take the accountability, right? But I would be a fool to not listen to the others. So for me, you really get to know, with big decisions, I actually spend a lot of time meeting the teams. Yeah, I've built space hardware. I can sense how good it, I listen to the team. I listen to the things that are not said. I basically figure out whether they're scrutinizing each other, whether we have a lead that squashes opposition. Those are all warning signs. You want to see whether I look at mistakes people are making. Are they, by the way, I don't care if they make a mistake, but are they making stupid mistakes and over again? Are they disciplined, right? So all that stuff, kind of, it's years of work that come together to that decision where I said, yes, we launch.
Where are you when you make that decision? Are you in a room with other people? Are you alone? Are you walking? Are you running? What are you doing when you actually make that call?
In many cases, I'm in a room with other people. But if I'm not sure, I will take a break. And I think well when I run. I think well in the shower in the morning. So, I mean, there are kind of points of clarity. If I'm not sure, I will never push into a decision. I mean, the way I always go is I go backwards, right? Suppose I'm sitting in the congressional hearing and I just blew up X and Y. Can I explain how I made the decision in a way that it made sense there? Space is hard. And by the way, every once in a while, we will fail. And I remind everybody of that. If you want to not fail, you're in that safe space over here. That's irrelevant. That's not how NASA got to where it is. It's not because people played it safe. It's because we do take risks. We do leave the launch pad, even though we know it's dangerous. With 1.5 to 3% likelihood, it will not make it out of the Earth's gravity, statistically speaking. So we take that risk, right? So just that itself. I will never. One of the things I really believe in is don't get pushed. If I'm not sure, I don't mind being the only guy who's not comfortable, and I will back off. I basically said, thanks, we're stopping the meeting. I appreciate that. If anybody has anything that is not being said, I will not make a decision for 24 hours. Send it to me by email, and I will go back. And if I find that there's more information I can gain that really is relevant, I'll do that. If I find, like you get into a place where more information actually doesn't help you because it adds ambiguity to the team, I make the decision right on the spot because frankly, I'm ready for it because I did the work. So it's not because I came in unprepared. I did the work for years in advance. I know, kind of have all these data points, and I've discussed them with my group of kind of diverse leaders who look at them from different perspectives.
Is there examples where you've made that call and it's turned out to be wrong, but you got a good outcome?
Yeah. So I'll talk about two decisions. The first one is, one of the first decisions I made. It was $1 billion assets. It's the Juno mission that was in orbit or is in orbit around Jupiter. And so we were in an orbit of a 50-day orbit, and we wanted to fire the engine and drop it down to a 15-day orbit. What that does, and I may have the date slightly wrong, but you get the point. I wanted to get, I have over 100 missions, so sometimes I mix up dates. I did not want to think we're going to talk about this, but anyway, I wanted to kind of increase the frequency of encounters by a factor of 3. That's what I wanted to do. The question was, do we want to do that? So the entire team, look at them from their point of view. They're, frankly, perfectly fine in a slow orbit. They say we need 20 flybys. It costs the taxpayer $50 million to just stay where you are. The principal investigator, everybody's like, let's just leave it where we are. There's risk. We want the minimum risk. And I'm like, well, what's the opportunity cost? You're spending $50 million to do the science. And so what I had to do is unentangle that kind of natural inclination, which I understand because I was in his role before, from the actual technical question. Is it important? So in that room, there were very few people who wanted to fire the engine, but I took the decision to fire the engine, and then we prepared for it. And as we prepared for it, all of a sudden we realized that the engine had a problem. It had a leak. Something was wrong with it. And frankly, what we needed to do is basically look at as we prepared for this what I believe is the exact right decision, we actually realized that we couldn't do, because now we would have to fire the engine. So I made a second decision. We would have to fire the engine in a state that it had never been tested. now a $500 million asset that's basically working, and I need to take a risk. Is it worth that risk? So actually, the second decision had to reverse that the first decision to fire. I actually decided not to fire because of the kind of enhanced and unknown risk. We thought the ancient people said we could probably do that. We just have never done it. And there has never been a burn that long in that configuration in any test environment. Okay, that's crazy, right? You don't, I mean, of course, I'm boiling it down to the quintessential 30 seconds of the meeting, right? Once you learn that, it's like you don't fire. So ultimately, we ended up not firing because we did the scrutiny in the first and the second decision. We set ourselves up in a way that actually made the science way better, because I had asked them to bring, yes, there's opportunity cost, but tell me what you can do extra science that you weren't able to do. So we actually moved it up. So by failing in my first decision, we enhanced the mission significantly.
I appreciate you sharing the details of that. You said there was 2 decisions that you recalled. What was the other one?
So the first one was let's fire, even though everybody opposed it. The second was let's not fire because, even though some of the technical people said we could do it, but we put enough scrutiny together that basically, again, I was wrong on the first decision. You could say, well, I'm sure somebody said, it's like, well, you could have just not fired and we're exactly where we are. It's like, no, that's exactly the right scrutiny, because in a congressional hearing, I could actually now explain to you how I cautiously spent that extra $50 million. It's not because I'm not handling the pressure well. We actually learned something that really matters. Learning is an important part of innovation.
How do you disseminate what you learn within the organization? Like, how do you share that knowledge?
That's actually a really good question, and I struggle with it. And basically what happens to me on a given day, I make multiple decisions, right? And for me, what I've started to do is sit down and talk people through the decision. It's almost like, see what I'm seeing. This is what, and really create that rigor in the organization and kind of show how the decision path goes, right? I asking questions out loud and talking through it. And so that's what I'm sharing in the leadership team. I worry sometimes just because NASA is so hierarchical, right? Because of the fact that only one signature matters, my schedule is oversubscribed by a factor of 10 every week, right? So I say no a lot more than yes relative to my time. That's my most important good, right? So for me, the question I'm asking, I'm spending enough time to actually disseminate things into the organizations, because it would be helpful for them to actually know this is the scrutiny we're putting on it. I try to do it and I ask people to do it, but I just want to tell you it's a question on my mind that I'm currently thinking about. I'm not, and the reason I'm saying it, it's like I see some of the same mistakes over and over again. It's like, no, I don't want, like, for me, what I really hate, if you really want to tick me off, come show up and tell me everything is low risk. That makes me believe you haven't understood your job, right? Don't make me feel good. Make me feel scared and then make me feel comfortable because you're dealing with all the risks. Don't come and say it's all low risk. It is not low risk. It's rocket science. And so for me, it's like, and at the beginning, everybody came with this because, these organizations have their histories, their leaders, like some leaders don't sleep well if they have problems. So they have pain aversion. It's a big leadership weakness. To not be able to carry worries with them, and those worries pulling them down. So, that the whole organization behaves in a way that they never bring a worry to you. You still have them, but you don't know them, right? So you get surprised, and I'm like, no, I need you to be worried more than me. Then I'm feeling comfortable. I don't want you to be calm. I need you to be worried. That's what I want.
What it sounds like you're really looking for, if I'm paraphrasing correctly here, is you're wanting to know that they've thought about it in a level of detail that's appropriate and accounted for those. And if they're coming to you and saying, I don't really have any concerns, then it sort of makes you question whether they've thought about it enough and deeply. And that's a red flag for you that you need to like dive in and evaluate.
Exactly right. So I look at those red flags and I listen really carefully to what's not being talked about. I listen really carefully.
Double click on that.
So I go into a meeting. I actually have a chart. I'm not sharing with people, generally speaking, but on that chart, there's technical, schedule, cost, team thing, like key topics. And I listen carefully. Are you talking about technical? What are your things that you're dealing with? We just talked about that. Are you worrying about it? Are you moving them forward? And what are your top worries? I want to know what they are. Then I want to know about your team. I want to know what do you talk about your team? How is your team doing? Under pressure as they are. Are they making mistakes? Are there almost mistakes you caught? Like how are you making sure your team is cohesive, motivated, excited? The relevant unit of innovation is a team. It's not an individual, right? So for me, I want to hear you talk about the team. I want to hear you talk about cost. You've thought about it. You've linked those things together. I want to hear you talk about schedule. So often for planetary missions, schedule is the most important variable because the planets need to be in the right place in the sky. So I can't take longer. I can only either go this year or 2 years from now to Mars, for example. Right. So because just Mars doesn't line up with the Earth the right way. So I can go there. So for me, I listen carefully for the white spaces on my chart or in my mental image of the entire collection of the mission. What are you not talking about? And that's where I'm going to go, right? So I sit there, I prepare, I look at every chart deck, every information ahead. Frankly, I block my schedule to do that in a very aggressive fashion. I take a lot of preparation time and I come in and now I listen really carefully and I tick off the chart. Are you talking about this? Are you really comprehensively doing that? And I may take one of those things and I drive like 5 questions into depth. And, I want to see whether you can go until you're finally, and there's some people I've never missed. I've never got to the end. There's some people 2 questions deep. I got them, right? And it's like, okay, they're a 2-question kind of person. There's the other one I've never found the end. After 6 questions, he's still going, right? It's I'm like, okay, don't worry about him, or her, by the way. The same is true with our managers. The same is true with our money people. Now tell me how, and I go after, and again, I want to know what you're not focusing on. And, as a team. And so that's where so again, be dishonest, red flag number 1, or kind of over exaggerate your comfort. And the second one is be blind, right? You're not seeing that part of your trade space. Kind of over focusing, I would argue, is my biggest challenge. So everybody focuses on schedule. Like, schedule. And it took me a long time. I could tell you a story about the James Webb Telescope. It's that story. I knew when I joined the job a month in where the problem's going to be.
Tell me that story.
Well, James Webb Telescope for 20 years. We've been working on it. It's one of the most difficult stories that we have in NASA, the international community. Canada built an instrument on it, so did Europeans, right? It's basically a $10 billion investment. It's the most complex mission ever done. It's basically a telescope, 6.5 meter mirror, protected by 5 tennis court sizes, kind of sun protection shields. It's really hard. The hardest thing to do is the telescope and the instruments. When I came in, that was in integration and test, and everybody focused on that. Well, there are 2 more swim lanes. One of them is the software operations piece, and the second one is the spacecraft bus. The spacecraft bus is just, the power, the communication, it goes behind the telescope and just attach it. And it's also that, sun shield deployment. Okay. So when I came in, kind of, like a good MBA, you look at it, the critical path goes through the telescope and all these other things are off the critical path by months. And I'm like, okay, I listened for a couple of weeks to the updates, and I said, "You're never talking about the bus. Can I ask you about the scheduled performance on the bus?" And again, I'm learning, right? I feel very inadequate, right? They're all much better than me, which is a feeling you have to get used to in my job. I'm not the smartest guy in the room by a long shot many times, but I'm there listening, right? It's like, well, tell me about the bus. And I look at the scheduled performance and they're losing schedule. And you basically take that scheduled performance, it's like, oh, we're doing fine. And we're so far off the critical path. I go talk to the director. He does the same kind of evasive maneuver. And I did not know yet how to do that. It's one of those things I learned in the last 5 years. I knew after a month this is going to be my problem. What I didn't know, it's one of the biggest lessons of my life. During that time, as well as the year before, this team had such challenges that it was making mistakes that cost the taxpayer of the United States $800 million. The mistakes themselves cost $600 million because of lack of focus, because of lack of cohesion in the team. Stupid mistakes of the type that, frankly, I would have kicked out undergrads out of my university lab if they made them. For example, they did not tighten bolts the right way. It's like, how can you have a $10 billion asset and not tighten bolts in a way that the fastener catches? Of course, it's a long story. They tried to solve another problem. And I'm 100% sure, Shane, that there's a technician who, by the way, thousands of those bolts. There's a technician up there who's tightening it. It's like, these things are not catching. Is that the right thing to do? And I'm sure that was being said, because it always is said, the technician knows. Well, but the team was broken enough that in that state, that information did not lead to action. We went to acoustic tests, the bolts start flying off. It's one of the most embarrassing things. The engines that are there, 12 engines, were flushed out with the wrong chemical. Instead of actually checking, the person who flushes it out, they try to clean it. That's exactly what they should do. They need to use the right chemical. Instead of checking with the supplier, a small company in upstate New York who did nothing wrong, instead of checking with them, they flushed with the wrong chemical. Now, the problem is they didn't talk to anybody about it. So the engines got added, the engines got added to the bus. Now I have 12 of those engines that I now have to cut out. I have to replenish the kind of valves or kind of seals that were etched away by the wrong solvent. And all that happened as nobody is focusing on it. And so for me, our focus, I tell you, is that, we're focusing on this because it's on the critical path. It's such a horrible mistake that people are making, and it's like, don't look at a chart like an MBA. And I know you have an MBA, so no offense to MBAs. We need them, we love them. But look at them as a leader, right? And of course, they shouldn't be in contradiction, but just go with the thing. Don't look at the chart and say, I'm fine, because my critical path moves. And that's what I learned in some book is okay. Everything off the critical path is what you're going to lose sleep over 1 year from now if you're not watching it. And it's not that you divert attention from the critical path, but you also need to focus off the critical path and pattern match. Go figure out, get to know about this team. I only focused on it a year later. I basically gave up. There's a the red flag version of space is you ask for an independent review team. I basically put the flag down and says, I lost trust. I did an independent review team that basically came back and says we need $800 million more to fix those mistakes and bring it together. And we had a horrible time on the Capitol Hill, explaining that to a disappointed science community that we did. And it was because of my mistake as a leader, not following my gut. I have in my notebooks that I had the mistake pegged. I just did not know how to get after it. In the meantime, of course, I stay connected with all parts of it, right? And frankly, I have the best team I've ever had. And as we're getting ready for the launch next year, right, that we're going to do so because the team got a chance to actually fix itself. But I could have given that chance a year, 1.5 years earlier.
Talk to me about that sort of the team fixing itself, and go into detail about how you change the how you rebuild the confidence, how you change the trust level, how you go forward with that, because I'm assuming the answer is not more bureaucracy.
That's exactly right. So for me, remember, I'm the guy who sits in Washington, right? I am not going to solve this problem. But what my job is to create the environment in which the problem is solved and to hold the leaders accountable for solving it, right? So what is absolutely critical is all the relevant leaders, all the way to the CEO of the company, agree on what the key priorities are. For example, the first priority is mission success. Yes, we want to launch as soon as possible. The first priority is mission success. We will not rush and make stupid mistakes, because every one of these mistakes in that environment costs us hundreds of millions of dollars. So saving a day and having 6 months to fix a mistake is just a bad thing. So it's really aligning that, getting together, also recognizing is there needs to be a stride we find. There's the right speed at doing something. So in other words, if like it's like biking, you teach your kid biking, it's like, there's the right speed of doing it. You can't do it any slower. It's not safer to go slower. You need to find kind of the speed of attention, the speed of learning, the speed of, find that right speed, kind of allow the team to get there, but insist on the right mechanisms being in place. For example, what was really important, one of the reasons airborne travel is so safe is because of the mechanisms that are put in place. Any pilot can say, we almost made a mistake. For me, that almost made a mistake mechanism is so important for big projects. Talk about the almost mistakes, because they surely will be mistakes if you don't fix them. What can we learn from almost mistakes? Also talk about the mistakes. And so for me, the question was, how do we do that? I actually met up with the leaders, met with the team to say, we got your back. We know we need to get better. We had a team. I basically replaced in my reporting structure everybody. And the simple reason for that is I wanted to basically create a before and after. I wanted to make sure that the after is one that we are together and we are one. We are locking arms. And frankly, I do that often in reviews. I push against one person and see whether the other one comes to rescue them. I want to know, like, do they let them sink? Frankly, I put more edge against one person. Sometimes I apologize at the end. Sometimes it's exactly the appropriate thing to do. But I want to see whether their partner helps, right? Are they helping each other, not against me, but together as a team to come do that? So for me, also staying in touch was important. I cannot stay in touch with all missions. In most cases, I delegate. Small missions, I delegate. I don't need to be in touch. For the highest missions, I meet with them. I meet with the leadership team. I have the leader on speed dial. I know problems before it comes to me because we're transparent about it. So that's what I do. So it's really, again, create a before and after. If you're in that much trouble, replace that. But then really recognize you're not going to solve the problem, create the environment for that.
I really appreciate that answer and the detail you gave there. I'm curious as to how the variance in presidential leadership affects your ability to build consistent programs.
It's actually a really interesting question. And I just want to tell you, of all agencies in the United States, NASA is perhaps the one that's the least partisan. So basically, it's kind of interesting that if you look, I came in under the Obama administration. I worked in the Trump administration. And if you really looked at the priorities, that did not, for example, in the science program, substantially change, right? We are, of course, part of a human exploration campaign to the moon and then to Mars, of which science is part. But if you take the Mars sample return, the mission, the Webb mission, they are there. And the reason for that is that actually the person who's in charge of choosing the highest priority science is actually not me. And I'm really glad for that. The process that we have built in the United States, and other countries have different processes, but is we use our national academies, the thought leaders in the domains, to say, what is the most urgent question that we should address right now? Not so what's the best, most important question, but what's the most urgent question? And that sets the priority. So I actually don't go argue with them. Should we go to Europa, the moon there? Should we go to Mars? Should we go to Uranus? We haven't been there in a while. I asked the science leaders with that collective, diverse kind of community to come up with that prioritization in a decadal plan. Every 10 years, we get that plan. And so I follow that. And that has created stability. Basically, both parties agree that that's the way to organize. And then the question really is, what's the money available? That is the political side, right? How does it go up and down? And of course, there's other priorities in the world than the science program. I understand that.
It sounds like that would be is there an equivalent for doctors and medicine? Because it sounds like that would almost be an ideal approach to directing some of that funding as well, from a government perspective, not from a private sector perspective.
There are some elements of NIH research that have a similar, National Institute of Health research that have similar type of prioritization scheme. I would argue that, especially with NASA and the space research, we have a better kind of consensus building process than many of the other disciplines. And it has really served us because it creates a constancy of purpose. So it's not so much like, I know if somebody comes in and says, hey, look, we want to focus on Earth science. What are the next missions? They are not questions I'm like, oh, let me start thinking about this. I already know what they are because for the last decadal, I've built that strategy and we're working on it. The only lever here is speed. Right. So how fast are we doing that? Because we know the Earth is a connected system. We need to focus on it. Right. And we know about global change. Now, the question is, how do we bring that data to the community so it helps them thrive on this changing planet? We already know that. Right. So the question is, how are we going? So for me, that is really a useful tool.
2 decades ago, the idea of SpaceX and its ambitions were sort of laughed at by the space community writ large. How do we ensure the biases of today are not slowing or blocking the ambitious goals of private sector?
It is true that I remember I wrote an editorial, something like 20 years ago or so, in which I basically made a simple point, and that said, hey, the top talent right now works at SpaceX. And if they have enough runway, financial runway, they will be successful because they have the top talent right now. And I remember how much I got attacked over that. I was a university professor, and frankly, the way I got to that assertion is by just tracking students, right? Where are the 3 Sigma performers, right? And then I called MIT and I called other universities. They said that the same for them. And I'm like, that's a pattern, right? And so yes, I mean, of course, that time has come and gone, right? SpaceX is a force to be reckoned with. I think Blue Origin, Jeff Bezos' company is right behind them. There's many others. Rocket Lab, a company out of New Zealand, I think is incredible innovation story for small launch systems. And it is true that in the government, right, that's where I work right now, it's a very difficult time in a following sense, right? And we need to make sure that we're not putting hurdles into the way, right? So it's in a following sense. So what happens is if I walk into a room in any place at NASA and I basically look at the leaders, a significant fraction of those very good people grew up in one specific environment, right? And they grew up in a place where, after Apollo, in which NASA was the only game in town, together with some contractors that also worked with other agencies on big systems, but in a contracting relationship using a specific set of contracting mechanisms and so forth. Okay, so where we are now is we have that other vehicle, a much more iteration-focused thing with failures, right? The first 2 SpaceX Falcon 1s blew up, right? And frankly, Elon tells the story that he was on the final money, right? The one that worked. It needed to work because it was the end of the company if it didn't, right? That's what he says. I don't know. So the question really is, how do we move forward with that? And it of course, the answer needs to be that we actually bring people who speak that other language on the inside of the government. See, diversity of thought is a really important criterion of team, whether it's in NASA or any other entity, right? And so for me, that's something I've focused on, right? I've worked in a venture fund, as an advisor. I've invested in venture things before, right? I've been on boards of companies, and so I'm not the best at it. I know that I'm not. I know what I don't know, but I know have network over there. And so what's really critical to me is that I'm not the best in a room in NASA. And if I'm not in the room, others are in a room who speak that language. Now, the good news is we're making progress and we're learning how to go forward. And of course, the proof of that is the crewed private vehicles that are operating now. That basically, there were a lot of thought papers that said that can never happen. It's impossible. And it's not just because of SpaceX making enormous leaps forward. It's also the government making leaps forward. So I think it's going to be a struggle as we go forward. And it's a struggle that we need to recognize as such and basically make sure that we all do our work in a way to advance it. It is a strength for us to have commercial entities. It's not in any way threatening. This is the future we want. There's no question about it. It's for us, the question is, how do we enable that? There's mistakes we can make in the government that are really horrible. Like if a pre-seed company pitches us for $100 million, we shouldn't just say yes because it's a pre-seed company. See, the venture capital community, because if it's a pre-seed company, only invested $1 million in it. Why? Because they see a lot of issues that are there on team, market fit, and so forth. So we need to bring that knowledge to bear too. Supporting of commercial entities doesn't mean that we say yes all the time. It means that our reaction is appropriate to what these companies are, and we become customers. We learn how to utilize these companies without owning them. I do not want to own these companies. I want to be a customer. And so for me, that's really the goal I'm after.
How has that affected your ability to recruit the best people and your internal culture and motivation with the rise of SpaceX and Blue Origin?
I think in general, actually, there's more excitement in space because of those partners. I actually don't believe that somehow sucked the energy out of it. The NASA brand remains one of the top brands in the world. And frankly, SpaceX added to that. They didn't subtract to it. And so for me, it has increased it. But what's also important, especially as we go to the leadership level, that we recognize that we need more arrows in the quiver in our leadership tools, right? We need to learn how to handle these environments and learn how to be agile, react to it, be learning organizations. And for me, what I've done in my job is really brought in a much more diversity in the leadership team in all dimensions, but especially to kind of reflect that environment. So we need, of course, the very experienced internal and NASA people who, frankly, know more about this agency and what's possible on the inside of the agency. But we, at the same time, also need the others who have worked in SpaceX and frankly, are or in related industries and are helping us make good decisions.
Do you think it changes NASA's role at all in terms of risk taking, where you can start to take more risks now, and when things work out, you can pass that technology to the private sector?
That's exactly what I want to do. Exactly right. That's exactly what I want to do. I want to focus on the things that a company cannot do because it's too crazy, it's too risky. So we have done things to for that, right? The James Webb Space Telescope that I just talked about is one of those things. It's not possible to do in a private setting, but at this moment in time. But as we go forward, it may be. I have a new program, the Commercial Lunar Payload Services Program to the Moon, in which I basically said, I'm buying at firm fixed price delivery services to the moon. Who wants to play? I did that after, I came into NASA and I saw these Google X Prize companies that had been funded by venture capital and other sources, not government sources. I was like, okay, if you have a company that could do that, I want to be a customer. By the way, I don't want to be the only customer. Not interested whatsoever to own that industry, but I want to be an anchor customer. And by the way, I'm going to take the risk. So what I did is I talked to every stakeholder, including those on the Hill, and say, look, the likelihood of that is not 100%. You should think of it as a 50-50 shot on goal. So we need to, like hockey, we need to take shots on goal to score. So for us, it's kind of being regular, doing that is really important. So we have a team that is running that is kind of learning to dance on that stage. It's a very different thing than what we're doing to Mars or to the moon in the past, right? It's a very different company, and frankly, this has lifted. So it's both leaning forward on kind of new things, but also kind of learning how to hand off, even in places where we're not 100% sure yet that it works.
How do you think about giving these companies not only sort of those contracts, but also valuable information that makes their product better versus opening that information up to the world so that the next Elon or the next Jeff Bezos gets a head start, and you're not solidifying one or two companies as the only option going forward and creating effectively a monopoly that just acquires more and more information from NASA, gets harder and harder to replace as time goes on. How do you foster competition in that space?
So we try wherever we can to make the information public, right? I mean, kind of whether it's the science data, how we do it, and we actually encourage people to write publications that said, how did you do it? We just picked up a sample at Bennu, this asteroid using a new technology. How did we do it? Go read the publication. We wrote it, right? There are some elements that we want to respect, right? The first one is intellectual property of individuals and of companies. If you, with your company, develop a new technology, I mean, frankly, I don't want to go stomp you out. I want you to be able to use that to lift your company, right? That's good. Innovation needs to be supportive in that way. So for me, I need to learn standing back, right? Of course, as a government person, I'm basically looking at you through the eyes of a taxpayer. Is it worth my money to pay for that license? I think the other one is that, of course, the laws that relate to export laws, right? We have legal boundaries on some things. Certain technologies we just can't. We don't want to. There's a legal boundary we're not going to cross. But within those boundaries, we are, trying to stimulate innovation by driving forward, by making information public. It's very common that we create kind of agreements with companies to help them, right? So our goal is, Elon himself has talked about a lot of stuff he learned from NASA in the crew thing that, frankly, our great experts taught him. It's not, that's what we want to do. And the next company can get the same service just the same way, right? So for us, we want to hand off what we can. So like you said, we can focus on the edge of innovation because companies cannot afford that yet.
Yeah, governments can take risks that private companies can't. I think that's a great place to end this conversation, Thomas. Thank you so much for your time. This has been fascinating.
Thanks for your time, and thanks for all you do. I've listened to your show many, many times. I run every day, so often you're in my ear when I run.
Oh, I appreciate that. Thank you.
Thank you.
Hey, one more thing before we say goodbye. The Knowledge Project is produced by the team at Farnham Street. I want to make this the best podcast you listen to, and I'd love to get your feedback. If you have comments, ideas for future shows or topics, or just feedback in general, you can email me at shane@fs.blog or follow me on Twitter at ShaneAParish. You can learn more about the show and find past episodes at fs.blog/podcast. If you found this episode valuable, share it online with the hashtag The Knowledge Project or leave a review. Until the next episode.